Hey, this is Kim.
And Amy. Hi.
Yeah, and we're here coming to you from the local Perkins. Yeah, and I hope you can hear us over the funky music in the background.
I think so.
I think they're okay. All right. Okay, so we're going to read to you from the Urantia book, but first we have 365 Days of Walking the Red Road by Terry Jean. Okay, so this is April 14th. This quote is from Dakawida, Cherokee. It's dated 1720, but when I look up this person, this is like the ancient peacemaker guy. He lived in the 12th or the 15th century. He was a Haudenosaunee. It said he was um, in the Iroquois Confederacy, but this book says he's Cherokee. So, mm, great peacemaker, Dekanawida. I don't know. See, I don't. Yeah, that's just disappointing here. To have a Cherokee Dekanawida, Dekawida,
Two hawks.
Dekanawida. No, it's Dekawida instead of Dekanawida. Dekanawida, no, Dekawida. Eddie Two Hawks. Dekawida, Eddie Two Hawks.
Cherokee. 1722.
1722. Okay, here we go. Okay, Eddie Two Hawks. I don't know. This is a lot of stuff about Native American stuff. What does this mean? What is? Okay, that could be. Okay, you know what? We gotta let it go. But people, Dekawida, Cherokee. I don't know what your destiny will be. It's just a quote, a cite from quotes. Luther Standing Bear, Martin Luther King.
Wow.
Man, there's a lot of stuff. Okay. So let's let that go.
Yeah.
Let's just see what this person says. Whoever you are, Dekawida. In all your official acts, self-interest shall be cast aside. You shall look and listen to the welfare of the whole people and have always in view not only the present but the coming generations, the unborn of the future nation. They say look to the 7 generations. Right, April 14th, that's today. Okay, then we're going to look at the Tao Te Ching. Tao Te Ching here. We're almost done here. Okay, so courage, patience, and paradoxes. Okay, beautiful picture. The world we live in requires great courage and patience. How about that, Amy? You feeling that? Those with great courage but little patience tend to kill or be killed.
Wow.
Those with great courage as well as great patience will tend to survive. What if you have patience but no courage? You'll probably be killed or live an empty life.
You learn to have courage while you're surviving.
Okay. But the great integrity never judges you for whatever path you happen to take. The great integrity never strives but always fulfills itself, never is commanded but always responds, never is summoned but always appears, never is impatient but all is done on time. Okay.
Not our time, though.
Not our time. Okay. Yeah, okay, so we're close to done with that one. Okay, let's read the Urantia book. Okay, we're on paper 42, section 6, Ultimatons, Electrons, and Atoms. Okay, just to familiarize you with, ultimaton is the smallest possible thing in the universe.
Okay.
You know how protons and neutrons are made up of quarks? They have quarks. Electrons are made up of ultimatons.
Okay.
Okay. Okay. I'll go a little bit. Should I
Okay.
go?
Yeah.
Or do you want to go?
You can go.
I'll go. Okay. While the space charge of universal force is homogeneous and undifferentiated, the organization of evolved energy into matter entails the concentration of energy into discrete masses of definite dimensions and established weight, precise gravity reaction. Okay, so they do have to package the energy force or something. Okay, you go.
Local or linear gravity becomes fully operative with the appearance of the atomic organization of matter. Pre-atomic matter becomes slightly gravity responsive when activated by X-ray and other similar energies, but no measurable linear gravity pull is exerted on free, unattached, and uncharged electronic energy particles or on unassociated ultimatons.
Okay, do you understand?
Yeah, no, that
No, I
just
don't
kind of went
understand
way
it.
over my
I
head.
don't understand it either. I don't know. I'm trying to make some kind of sense of it. But pre-atomic matter. So there's
Mhm.
matter that's before, like
That's
quarks
atom,
and stuff, right?
Yeah.
So it's slightly gravity responsive when it's activated by an X-ray or something.
It's crazy though,
I
because how do you put that in perspective of X-ray compared to our X-ray? Like
it's not. Yeah, it's a different. Like X-rays are always going through everything. It's not like the doctor makes them at the
Right,
radiologist's office. No, because X-rays are always going
I
through
know,
everything.
I know.
We just can.
It's
You know,
like
we
hard
just have.
to like.
Yeah.
There's no way to visualize in my mind.
Okay, I'll go a little bit. Okay. Ultimatons function by mutual attraction, responding only to the circular paradise gravity pull. Without linear gravity response, they are thus held in the universal space drift. Ultimatons are capable of accelerating revolutionary velocity to the point of partial anti-gravity behavior, but they cannot, independent of force organizers or power directors, the actual celestial manipulators and stuff, okay, they attain critical escape velocity of de-individuation, return to the puissant energy stage. Right. In nature, ultimatons escape the status of physical existence only when participating in the terminal disruption of a cooled off and dying sun.
Oh wow.
The ultimatons, unknown on Urantia, slow down through many phases of physical activity before they attain the revolutionary energy prerequisites to electronic organization. Ultimatons have three varieties of motion: mutual resistance to cosmic force, individual revolutions of anti-gravity potential,
That makes sense.
and the intra-electronic positions of the 100 mutually interassociated ultimatons. 100 mutually interassociated ultimatons. Mutual attraction holds 100 ultimatons together in the constitution of the electron. So an electron is 100 ultimatons.
Yeah.
Okay? And there are never more or less than 100 ultimatons in a typical electron. Okay, no, they haven't been able to split apart an electron, see what's in there. So that's like a mystery, but okay, science is going to find 100 different ultimatons in an electron someday. The loss of one or more ultimatons destroys typical electronic identity, thus bringing into existence one of the 10 modified forms of the electron. Okay, you go.
Ultimatons do not describe orbits or whirl about in circuits within other electrons, but they do spread or cluster in accordance with their axial revolutionary velocities.
So they go around.
Thus,
They
thus
spin.
determining the differential electronic dimensions. The same ultimatonic velocity of axial revolution also determines the negative or positive reactions of the several types of electronic units. The entire segregation and grouping of electronic matter together with the electric differentiation of negative and positive bodies of energy matter, result from these various functions of the component ultimatonic interassociation. So even if some of them they work together yet separately, but in a cluster and individually.
Okay.
I don't know how to.
No, I don't know. This is so, it's so weird. It's like, yeah, I don't know.
But somehow it works.
Somehow it works.
Each atom is a trifle over, I can't read that,
100 millionth
of an inch in diameter, while an electron weighs a little more than 1/2000th of the smallest atom, hydrogen. The positive proton, characteristic of the atomic nucleus, while it may no longer
maybe no
larger than negative electron, weighs almost 2,000 times more.
Right. So the electrons are a lot
Yeah.
smaller than the protons, right?
It's weird that they describe weight because we can't feel it.
No. Yeah. You can't feel it.
If the mass of the matter should be magnified until that of an electron equaled 1/10 of an ounce, then were its size to be proportionately magnified, the volume of such an electron would become as large as that of the Earth.
Okay, so if the mass of matter was magnified
Yeah.
so it'd be so big. It'd be so big, but it would be the size of the Earth, but it would weigh only 1/10 of an ounce. How can something be that big and weigh 1/10 of an ounce?
If the volume of a proton, 1,800 times as heavy as an electron, should be magnified to the size of the head of a pin, oh my God, this is insane. Then, in comparison, a pin's head would attain a diameter equal to that of the Earth's orbit around the sun. So, the only way I can picture it is if you move your hands back and forth really fast, you can feel the energy.
Yeah, you can.
So
I can feel when I
the-
hold my
yeah.
hands still, probably even better, because I can hold them like this, and I can feel that energy tingling in my fingers.
So that's the only way I can visualize what they're trying to say is when I do that and get an idea of the circular and the
Yeah. No, it's hard to.
and you can feel the push and pull and
Yeah.
but to visualize this, that's insane.
Yeah.
A pinhead.
Well, yeah, like a
And
pin
then,
head. Yeah, yeah.
And
The
we like
proton.
this. It's just insane. This would be fun to see a science teacher try to help us visualize this. That would be really cool.
Yeah. If a volume of a proton should be magnified to the size of the head of a pin. Oh, then the actual pin's head would be okay, really big. So yeah, okay, all right.
I would love to see a teacher show us how.
There was somebody once that tried to do like they were driving like across the country and put up like signs like on a highway like the orbit of like if this was the sun, like if the sun was like Los Angeles or something, and you're driving across to like DC or something, right? Then so far away you drive a ways on that highway, and then there'd be Mercury's orbit. This is how far you
that's
get
cool.
to Mercury, and this is how far you got to
That's cool.
yeah.
That would be fun.
Yeah, I'd like to go on that road trip. But anyway, it's crazy. I mean, it's really wild, interesting information. And
it takes a certain type of person to appreciate this. So, like normal people can't just read this because they'd be like,
yeah,
you have to have an appreciation and a knowledge of some of this.
Little bit. I've got enough to just kind of like, but I think the problem is like religious people get mad at it and scientific people, because it falls between the cracks because they're so polarized. This is trying to
Which
bridge
is sad.
Yeah, which is sad, but it'll come together eventually. We just have faith and stuff. But anyway, okay, that's it. We have to go. All right.
Bye.
That's it for today. Yeah.
It's been a while.
Yeah. All right. Thank you. Have a really good day. Bye. Wow.